Alright, so there's going to be another problem like this in the test number 41. Basically you've got an object on a hill and you need to know either A, how much does the object weigh if you know how much force it takes to hold it up, which is number 41, or you might be given the mass of the object and the amount of incline and be asked how much force would it take to keep the object from sliding down the hill, or so on and so forth. So I made excuse me, I made one quick change from the diagram in the textbook. This is actually the diagram from the example, and they use 24 degrees, so I just changed that to our 15 for the problem. If we look here, 500 pounds is needed. Where does that go? 500 pounds needed, that is this vector right here. Okay, this vector is the vector that represents the force required to keep the object from falling or sliding down the hill. So that's 500. The 15 degrees we've already marked, assuming there's no friction, which is really hard to do actually in real life. But anyways, we're trying to find the weight of the cart. We are trying to find this vector, we'll go blue. We want to know this vector right here. Okay. Gravity always is represented by a vertical line. No matter what the incline is, gravity is always vertical. And also then, the force required to keep the object from falling down the hill, or how much force is required to pull it up a hill, that information is always parallel, right here, parallel to the hill. So if you think about this triangle, I will explain how we get this angle, theta. Let's see. Let's go. Let's change our font to be a little bit smaller. Okay. In order to find red, this theta right here, the shortcut is this theta is always going to be equal to the angle of incline of your hill. But why is that? Well, if we look at the right triangle that I just drew from C to S to T, that right triangle has one corner 90, one corner 15. That leaves alpha up here to be 75. 75. Right? Now we're going to take and look at the PRT triangle. Okay? In that triangle, we still have a 90 degree, because PR is the force perpendicular to the hill. So we get a 90 degree angle. We have a 75 degree still from our first triangle. That leaves us with this corner to be 15. So that was just a quick side note why this angle is always the same as the angle of incline. So what I've been doing in class, if I take and just rotate that triangle, if I just take it and slide it down 90 degrees counterclockwise, here's the triangle that I have made. Okay. Now the TS, this blue, I'll mark that as my X, my unknown. That's what I want to know. That hypotenuse represents the force of gravity, or the weight of our object. So let me get back to our normal pen. I can set up the trig ratio sine of 15 degrees equals 500 over x. And then solve for x, we get 500 over sine 15. And that comes out to, you just plug that in the calculator, in degree mode of course, and you get around 1,932 pounds. And that's your answer. That's how much the cart weighs. Now granted that doesn't look like a cart, but imagine that to be a cart. It could be a car itself, it could be anything, but the idea is the the amount of force being applied, 500 pounds, is less because the hill is absorbing some of that force. So the overall is 2,000 pounds.